Okay, hi everyone. In this video, I will go through the speed quiz on exponential and logarithm. I hope that you had the time to go and try the questions by yourself first. Then once you have tried them, then you can watch this video to see how I work through these different questions to arrive at the solution. Okay. Because there are so many different laws and properties of exponential functions and logarithm functions, the method that you use may be different. So therefore, you don't expect to see the exact same working as what you should do. But as long as you follow the right steps to obtain the right method, then that should be okay. Okay, so let's look at question one. Question one, solve the equation. So every time you see solve the equation, it means that you have to find the value of the unknown that will satisfy this equation here. And in this equation, I want to find the value of x. Okay, so what I want to do is to essentially extract out this x over here. So let's look at this. I have 16, I have 6, and I have 2. It's always easier to simplify all these bigger numbers. So we know that 16 is essentially 2 power 4. So we can rewrite this equation. This is 2 power 4 times 2 power 2 minus x equals to, then I have over here 2 power 1 minus 2x, and I have times. So over here, right, you see, I have this 6 power 2x over here. And if I want to find x, right, one easy way which I would think for myself would be to bring down this 2 over here. So if you recall your laws of indices, this is the same as 6 square, the whole thing power x. Okay, so if you recall what you have learned in the laws of indices, we can rewrite this to be this, and therefore 6 squared is 36. So this will be 36 power x. Okay, so by doing so, you can see that now my powers all have this x over here. It will be easier to solve. Okay, so over here, what I'll do is that I'll have 2 power, same base, multiply. If I multiply two indices with the same base, I add the powers together. This will become 4 plus 2 minus x. It will be 6 minus x equals to 2 power 1 minus 2x times 36 power x. Then after that, what I can do is that I can, since I have these two numbers base 2, I can divide them to simplify them. So this will be simply 2 6 minus x, then divide by this. So the power will become minus away, 1 minus 2x equals to 36 power x. Then therefore I can further simplify this. This will become 2 6 minus x minus 1 plus 2x equals to 36 power x. Then we continue simplifying from here. Okay, this will become 2 power 5 plus x equals to 36x. Okay, then every time if you recall, what we have learned before is that the purpose of learning logarithm is really so that we can bring down unknown powers. So now I have one term on each side. Okay, I can apply log to both sides. This will become, and I can bring down the power by my power law. So this is 5 plus x log 2 equals to x log 36 in this case. Okay, a common mistake that many people do, once they see this, they are not sure how to carry on. So a tip is that remember the aim of this question is to find the value of x. This is 5 plus x, and this log 2 is simply just a number. So what I can do is that I can simply expand out this bracket. So this will become, if you expand out, it will be 5 times log 2 plus x times log 2. So this will become 5 log 2 plus x log 2 equals to x log 36. Remember again, all these numbers are just, all these log functions are just numbers. You can imagine this as, for example, 2x. But now instead of 2x, the 2 become log 36x. Okay, so over here is going back to what you have done in sec 1. How to find the value of x? We shift all terms containing x to one side. So this is simply x log 2 minus x log 36 equals to negative 5 log 2. Okay, then after I factorize out the x, this is simply log 2 minus log 36 equals to negative 5 log 2. And therefore, from there, I can solve for the value of x. X simply equals to negative 5 log 2 over log 2 minus log 36. Okay, then if you key this value into your calculator, negative 5 log 2 log 2 minus log 36, my answer will be equals to 1.20 in 3SF. Okay, so this is the solution, my word solution to solving question 1. Okay, of course, there are different ways to solve this question, but as long as your ideas, you apply the laws correctly, there shouldn't be any issues. Okay, alright, so let's move on to question 2 now. How to solve question 2? Solve the simultaneous equation. So over here, I see a lot of big numbers, and whenever I see big numbers, a tip is that we want to reduce them. So over here, you can see that I have 27 and 729. Solve the simultaneous equation means that I want to find the value of x and y. So what I can do is that I can make them all the same base. 27 power x can be reduced to become 3 power 3x divided by 3 power y equals to 729 is actually 3 power 6. So I can rewrite this. This will become 3 power 3x minus y by a loss of indices equals to 3 power 6. Therefore, same base, I can now compare the power. 3x minus y equals to 6. I can make y the subject since it's easier. Y equals to 3x minus 6. This is equation 1 that I can obtain. Okay, let's look at the next one here. From this second equation here given, okay, I have 1 over 4, I have 2, I have 16. I hope you can recognize that a common base I can turn all these numbers is to base 2. So let's look at this equation here. 2 power 4x times 1 over 4, I can actually rewrite it to be 2 power negative 2. The whole thing power y minus 1 equals to 16. Then I simplify from here. 2 power 4x times, this is negative 2, then this negative 2 power y minus 1, by my loss of indices, this will become 2 power negative 2y plus 2 equals to, then now 16 I can also reduce it, 16 is essentially 2 power 4. Okay, so therefore this is simply 2 power 4x minus 2y plus 2 equals to 2 power 4. So now that I have the same base, I can compare the powers straight away. 4x minus 2y plus 2 equals to 4. If you want to simplify, you can simplify further. 4x minus 2y minus 2 equals to 0. 2x minus y minus 1 equals to 0. Therefore, y equals to 2x minus 1. This is equation 2. Okay, so from here, once I've obtained these two equations from each of this original equation, my last step, okay, from here, I know that equation 1 is equal to equation 2. So therefore, 3x minus 6 equals to 2x minus 1. X is equal to 5. Okay, therefore I sub x equals to 5 into, let's say, equation 2 lah. It looks easier, right? So therefore, y is equal to 2 times 5 minus 1 equals to 9. Okay, so this is the solution to question 2. Alright, so let's move on to question 3. Question 3. Given that this log base Rp equals to Q and log base QR equals to P, express this thing in terms of P and Q. So over here, let's write this down first. I want to start log base QP. Okay? And I want to turn this log expression in terms of P and Q. I look at the information given from the question. I can see that the question, the base given, I have a base R over here. Over here is really base Q, but this number here is R, so we cannot do anything with this. What I can do is that I can make them base R first, so that I can make use of this equation given over here. So we recall your change of base formula. If I want to make them base R, log base R, then this will be log base RP over log base RQ. Okay, Then from here, I know that I can simplify further. This will be equals to, I know that log base RP is Q. And now I want to find log base RQ. But over here, the question, this information given here is that log base QR. So what I can do is that I can turn this into log base Q instead. So this will be equals to log base Q over log base QR. Okay, and then from here, what I'll get is that this will be equals to Q over 1 over R. Sorry, not over R, over P. Okay, based on the information given here, so let me highlight clearly. This is from here, and this part here, okay, is from here. Okay, so now the last step is, I think some of you should be able to do it, but let's say if you get confused, I see a fraction within a fraction. Do it step by step. This is simply equals to Q divided by 1 over P. Correct? Because this is the big divide here, Q divided by 1 over P. Then you learn in primary school, this is simply Q, that I flip this thing over here, if I turn this to multiplication, Q times P. So therefore my final answer is simply equals to PQ in alphabetical order. Okay, so this is for 3A. Let's look at 3B now. Given this equation here, express M in terms of N. So that means I want to make M the subject. So over here, what I can do is that from this original equation here given, okay, let me write this down so it's clearer. 3 log M cube root N, maybe I turn this cube root into a power 1/3, okay, equals to 2 plus 2 log M minus log N. So what I want to do is I want to make M the subject, right? So therefore, let's look at how we can simplify this. I see this 3 over here, and I see a cube root here. By a power law, you can actually bring this 3 upwards here, so that this M, you can actually make this cube root disappear. So from here, I can actually turn this into log M cube N. Okay, if you recall your power law, equals to, then over here, 2, I see 2 log functions here, okay, but remember, I cannot apply my the quotient rule straight away, because 2 log M minus log N, okay, let me write this at the side, very common misconception. Log M minus log N, we know that by what you have learned in the laws of logarithm, this is simply log M over N. But if I have 2 log M minus log N, this is not the same as simply 2 log M over N. Okay, this rule only applies when this coefficient here, the number in front of this log is a 1. So over here, you see that I have a 2 over here. What I need to do is that I need to bring this 2 up so that I'm able to apply my quotient law. So simply, if we look at this, this is simply equals to 2 plus log M square minus log N. Okay, then afterwards, now that I have a log M square minus log N, the coefficient here is 1, I can now apply the laws of logarithm to simplify further. Log M cube N equals to 2 plus log M square over N. Okay, then after that, I can see I have log terms, right? We can just shift our log terms to one side, so over here, this is simply log M cube N minus away log, then I have a M square over N equals to 2. Then I can simplify this further. This is simply log M cube over N divided by M square over N. Okay, then I can continue simplifying from here, equals to 2. Simply, this is simply log M cube N times N over M square. Okay, equals to 2. Therefore, I can continue simplifying. This is log mn square. I don't need square bracket anymore. Okay, so log mn square, if you simplify this, you go to 2. So if you recall, how do we turn from a logarithmic form into the exponential form? Okay, this log here, when I write algebra, we assume that the base here is 10. So simply, we can turn this into mn square equals to the base 10 power 2. Okay, then from here, the question wants us to express m in terms of n. So that means I want to make m the subject. Simply, m is equal to 10 square, which is 100 over n square. Okay, and this is the solution to question 3b. Okay, quite simple if you can apply the laws of logarithm very carefully. Okay, alright, so this is the first three questions of this. Okay, now I'll quickly go through the last two questions as well from the bonus questions. Okay, so for the next question here, solve the simultaneous equations. I'm given two equations, this equation here and this equation, giving a solution in this form over here. So when I want to solve simultaneous equation, okay, it means that I want to form equations such that I can find the values of x and y. Okay, so over here, right, if you look at this, I'm given 2x equals to 3y. Notice that there's nothing I can do about this equation anymore. I can't simplify the base. I have two unknowns over here. Remember, when we solve simultaneous equations, we always try to make one equation one unknown. Then we can solve it. So over here, given this additional information here, I know that I can make one of them the subject. Let's say I make x the subject. X equals to 1 minus y. Okay, so therefore, if I sub this inside, this is the same as 2 power 1 minus y equals to 3 power y. Okay, so then from here, very simply, we can find y already. If you recall again, the purpose of logarithm is so that we can actually a usefulness of it is that we can bring down unknown powers. So simply, if I apply log to both sides, okay, I'll get 1 minus y log 2 equals to y log 3. Okay, this is applying my power law as well. If you need me to break it down, let me just add one more step in case you are confused. Log 2 1 minus y equals to log 3 power y. Okay, then my next step from here to here is simply to bring down this power using the power law. Then from here, simply I want to find the value of y. It is the similar concept to question 2. I can expand out this bracket here first. 1 minus y times log 2 is simply log 2 minus y log 2 equals to y log 3. So if I want to solve for y, I just need to make y the subject. I shift all terms containing y to one side. So over here, this is simply y log 2 plus y log 3 equals to log 2. Therefore, factorize out the y. Y is simply equals to y log 2 plus log 3 equals to log 2. Continue simplifying from here. Log 2 plus log 3 by the product rule, we know that this is simply y log 6 equals to log 2. Okay, so therefore, y is equal to log 2 divided by log 6. Okay. And once we have solved this from here, then after that we can simply just sub this back into this equation for x. So therefore, from here, sub y equals to log 2 over log 6 into I call this equation 1 to be clear, into 1. Okay, so therefore x is equal to 1 minus log 2 over log 6. And since this question wants you to express your answer in this form over here, that means I have to simplify this expression. Okay, 1 minus log 6 fraction and make them same denominator. This is simply log 6 over log 6 minus log 2 over log 6. Simplify them, log 6 minus log 2, the whole thing over same denominator, log 6. And by the quotient rule, we know that log 6 minus log 2 is simply log 3 over log 6. Okay, and with that, I have solved question 4 as well.